Hey guys, so today we're going to practice working on ANOVA. This is some data I found on the web that I thought was interesting because it relates to some of the work that you guys are doing in your projects. It relates to some of the projects you guys have selected. So this is data on the time it takes a rat to complete a maze based on the environment supplied to them. Or more specifically, each of these numbers is the amount of seconds it takes a rat to complete a maze, and it's separated or grouped by the environment provided to them, where impoverished is just a standard cage with no amenities. Standard, they get food and water. Enriched, they get some toys, and super enriched is even more resources available to them. So the researcher is basically trying to figure out what relationship or what impact environment might have on a rat's ability to complete a maze more in a timely fashion. So the first thing you should do before even starting your ANOVA analysis, hopefully you recognize this as appropriate for ANOVA because you have several groups and quantitative data. But before even getting into the ANOVA, let's do some summary statistics because it'll be helpful both as a sanity check when you're doing your calculations, but also when you get your results to ensure that it makes sense based on this basic EDA. So I'm just going to start by taking the mean of each group. All right, and just looking at this data, and let's take the overall mean as well because we know that's going to be helpful in our calculations, and it's good to have like not really a baseline, but some overall metric for comparison. But looking at this data, it looks like as the environment gets nicer, the time to complete, or more enriched, I should say, the time to complete the maze decreases, right? So already we have kind of an inkling, an intuition that the results of our ANOVA will be that we do reject the null, that there's no difference in the mean of the groups, and we'll conclude that there is some difference, and specifically that difference looks like it might even be linear, looking at the difference between the types of environments. This isn't really an ordinal variable, but there is a directionality to it, right? As I move to the right, the environment gets nicer and nicer. Okay, so this is my overall mean. What else do I need to calculate my ANOVA? Well, I need my errors. So let's do that, and I'm going to label things so I don't make the mistake I made last time with selecting the wrong cells. These are my means, this is my overall mean. Let's calculate my errors. So my errors are going to be each observation minus the mean for that group. And I'm going to sticky, how do I sticky in this keyboard? I think it's function. Yeah, there we go. I'm going to sticky this with the number 8 only, because I do want the column to change as I drag to C, D, and E, but I don't want row 8 to change. And you'll see what I mean as I drag this out. So these are all my errors. I'm taking every data point minus the group mean. And you'll see what I mean, because if you double click, it shows you the cells it's related to. So this is taking this data point, subtracting its group mean. This is, this error is calculated by taking the associated data point and its group mean, and so forth and so on. You see the pattern now, and that's what I meant when I mentioned stickying that data. So these are all my errors. However, I don't really want just the raw errors, right? I want the square errors. So let's go ahead and square all of these to make it easier, limit the amount of cells we fill with information. So these are all my errors. And you might remember for an ANOVA table, there's a few things you want to calculate. There's what I called group. There's also the errors. And then there's total, which is really for sanity checking purposes. It doesn't go into your F statistic. But the error, what you're doing is we calculated them here. These are all my square errors, so the sum of them is going to give me my SSE, or sum of squared errors. So I'll label these as SS. And then for group, what I'm going to do is I'm going to take each of the group means minus the overall mean, right? And this one I should sticky because it's not going to change at all. So I'm going to leave the sticky on both the F and the 8. I shouldn't have done this there rather, but it's okay. We'll just drag it out. So these are each of my group errors, right? Let me actually do that over here. Group. Do I want to say sum of squares? We'll say group squared. And so ignore this. I shouldn't have done this up here. I'll do this down here. We take the group mean minus the overall mean. I'm going to sticky that so it doesn't move as I drag. Right, and now here's each of those. Let's square them like we did the errors, just to limit the amount of cells in which we're pasting numbers in. Okay, and now our sum of squared group is going to be the sum of all these. But you might remember there was a double summation here. So we have to actually multiply each of these by the amount of rats in each group. So it's pretty easy here because it's the same amount of rats in each group. It's 6 rats per group, if I counted correctly, or is it 5? 1, 2, 3, 4, 5, which tells me that the errors are wrong because I have 6 values in errors. So I'm guessing, so first let's fix this. Let's multiply by 5. Now over here what's going on is I'm taking this blank cell and subtracting the mean, I'm assuming. Yeah, so we want to erase this row because it's not an error, it's not an actual data point. Okay, so now we have our sum of squares group, our sum of squares error, and as a sanity check I'm also going to calculate the sum of squares total. So to do that I take each data point and subtract the overall mean. So I'm going to do total squared. This is error squared, I didn't label that correctly after squaring it. So total squared. So I'm taking each data point, subtracting the overall mean, and we're going to sticky it completely in the F and the 8 so it doesn't change, and I'm going to square it again. Okay. And this is a good sanity check to make sure you've done your work right. You might have heard from other Sorry about that. You might have heard from other math professors that if you get the same answer 2 different ways with 2 different approaches, you're very likely right. So these sanity checks are going to be really important because there is no partial credit if you get the wrong answer but your process was right the vast majority of the time, just because it takes time to grade. And let's just make sure that's right. And I can see when I highlight these 2 that they sum to 458.95, which is exactly what I expected. 458.95. So that's just a quick sanity check that told me I did my sum of squares right. Now let's do my degrees of freedom. This is much easier. For the group, there are exactly 4 groups, right? J, if we want to refer to that as my index, goes from 1 to 4, and I'm going to subtract 1 because I'm estimating the overall mean, so the degrees of freedom for group is 3. Degrees of freedom for error is a little more complicated. I could count the number of data points, or I could take my number of groups, multiply by the number of rats in each group, which is 4 times 5 is 20. If I highlight them, Excel should tell me that the count is 20, right? So that's my number of data points, but then I also have to subtract the number of groups because I'm estimating a mean for each group. So this is actually going to be 20 minus 4, which is 16. And again, you can do a sanity check here because you know the sum of squares total is your number of data points minus 1, which is 19. And of course, 3 plus 16 gives me 19. So this is all good sanity checks to make sure I created this table correctly. Now if I want my mean squared error and my mean squared group, I'm just going to put an M here for mean. And or maybe I should put MS for squared. So MSE is going to be 135 divided by 16. And MS group, and you'll sometimes see people, instead of saying group, they'll say block or treatment. What else? They might also refer to it as regression, because ANOVA is nothing but a special case of regression. Just like the ANOVA test is a special case of the F test, the ANOVA process is the same process as regression when your independent variable is categorical. So let's calculate those. And I have my mean squared treatment group, whatever you want to call it. I'm going to stick to group in this class. Mean squared group here, mean squared error here. And the last step is to calculate my F statistic, which is as simple as taking the group divided by the error. The error always goes on the bottom. And this is my F statistic, 12.71. The last piece now is to get my p-value. And you might remember in statistical software, you can get this very easily by supplying the statistic and the degrees of freedom. So let's do that. We want the right tail in this case, so I'm hovering over f.dis.rt for right tail. And it tells me it's asking for my statistic. I give it my statistic. It wants the first degrees of freedom, which you might remember is the numerator's degrees of freedom. And then it wants the second degrees of freedom. And I get a p-value that's clearly way less than my standard error of 0.05. Sorry, I misspoke earlier. I did not mean to say standard error. I meant to say less than my type 1 error, or also known as alpha, of 0.05. So in this case, we would reject the null and conclude that there is a difference between these groups when it comes to the time for a rat to complete the maze. Let's do a little more analysis though, because we know there's some difference, but we want to also do the pairwise test to identify among which pairs those differences exist and which ones are, among which pairs differences exist and what the directionality of those differences is, which we know from EDA, we have some idea of, right? It looks like as the environment for rats improve, their time to complete the maze also improves. So keeping that in mind, we'll run all our t-tests. How many t-tests can we run? Well, there's 4 groups. And if we do 2 pairs for each, right, that's going to be 6 different pairs. 2 pairs in each. If we do it pairwise for 4 groups, that's going to be 6 different pairs we could do, right? Impoverished with standard, impoverished with enriched, impoverished with super enriched, standard with enriched, standard with super enriched, enriched with super enriched. Or you could think of it as 4 choose 2 is an easier way to do that calculation. So if we were using the Bonferroni correction here, we have our normal alpha of 0.05, but we're going to divide it by 6 because we're going to be doing 6 different comparisons, 6 different t-tests. And that makes our new alpha, through the Bonferroni method, 0.83%, which is really small, less than 1%. It's going to be, we're going to need overwhelming evidence to reject it. And in this case, because the differences are like pretty significant, we might meet it. But I also want you to remember, we learned about Tukey's honestly significant differences approach, and we could also use that approach. Again, it's a distribution. I don't know if Excel knows it. Let's see. It doesn't look like it. Let's see if no. So it's not something Excel knows. But other statistical software will get you that. You'll just plug in the parameters, which you might remember are the number of groups, which is going to be 4, your first parameter. And then your next parameter is going to be the number of observations per group, -1, the number of groups, -1, which in this case is going to be 4 times 3, which is 12. And then the associated alpha, which is going to be 0.05. And that will give you the statistic that the absolute value of your test statistic, the t-test statistic, must be greater than in order to reject. So hopefully this was a helpful exercise. You're going to do the same exact thing on the quiz. Reach out with any help or questions. You don't have to use Excel. Use any tool you'd like. If you know R, it's like very trivial. Same thing in Python or SAS. Even in Jump, this is trivial. But the quiz is broken down into pieces, and you won't be able to get the individual pieces without doing some of the calculations by hand. And I did extend the deadline for the quiz to tomorrow because I posted it a day later than normal. So it's now due Saturday instead of Friday. And I will post the answers to both the quiz and the homework Sunday most likely.